objective with this project was to make an electric skateboard for a lot less money than they normally sell for. So on the right you can see a traditional non-powered longboard, and on the left you can see our electric skateboard. We elected to have a single wheel in the back because that simplified our drivetrain design greatly, and we were able to mount the motor directly to the board itself. Whereas if we had kept a traditional truck in the back, we would have had to modify or create our own truck and attach a motor to the hanger so that it would move with the wheels as you turn. You can also see that the wheelbase on our electric skateboard is somewhat shorter than the longboard on the right. This is to try and mitigate the turning radius issues that we suspected we would have and that we did end up having. So our electric skateboard has a very wide turning radius due to the fact that the wheel in the back doesn't provide any sort of turning force, it just tilts. We also designed battery enclosures in the middle of our electric skateboard. These battery enclosures were originally designed to hold much larger batteries than we were planning for, and then we would have the electronics stored on the tail of the board. However, we found out that our electronics would all fit in the battery enclosures, and after we had to change our ESC, we were able to fit all of them within that battery enclosure, thus simplifying our design and allowing us to have all the electronics stored within the board, and then just a single set of wires running back to the motor. We decided to go with the chain and sprocket design because it would be very robust and we wouldn't suffer any issues like slipping and so on. Normally electric skateboards use a timing belt design, which is quieter, but we have a much longer distance between our wheel since it's bigger and our motor, and we also are planning to transfer more force through the chain because we have a single motor instead of a double motor setup. You can also see that we have our 6-inch caster wheel here with an aluminum hub. We drilled holes into the hub of the wheel, and then we attached 1/2-inch aluminum standoffs made out of round stock, and then this is our 0.1-inch water jet steel sprocket. So we were able to size the sprocket on the water jet so that it fit correctly, and we made the standoff so that the chain would have enough space between the wheel and the board. You can also see the shaft mounts with a double screw clamping design. Those were also water jet and then machined. Our board has a wheelbase of about 30 inches. It has a 4S ESC, which can handle up to 120 amps. Our gear ratio, the motor sprocket has 11 teeth, and the wheel sprocket has 32 teeth. The wheel on the back is a 6-inch wheel. We have a 149 kilovolt 6374 Turnigy SK3 motor. We also have a 9-inch conventional truck in the front. Okay, we're good.
Okay, so this is our finished product, the electric longboard. The deck, whoops, let's see, the deck, the shaft mounts, and this motor mount was all created using the water jet. And the black pieces here, the wheel guard and electronics casing, were fabricated by the 3D printer. So this made our work a lot easier. So the only thing we really had to do was cut out the shaft and installation, basically. Here we have 2 sprockets, the chain. This is our clamping mechanism for keeping the shaft in place, right there. Let's see, the front is mostly unchanged compared to a regular longboard. You have your truck here. So you'll notice that we have some grooves here, and we have a piece of acrylic. This is so we ran into a problem of biting initially. So these 2 features would help alleviate that concern. Let's see. initially the chain was also too loose, but after playing around with it and creating a smaller sprocket for the wheel, it's just about right.
Here is our electrical setup for the longboard. We start off with a 4S LiPo that then powers our ESC. From the ESC, we use the BEC that it comes with it to feed 6 volts to the Arduino. The Arduino then powers the USB shield, which then powers the dongle. For our controller setup, we have a dead man switch in the back that we have to press down to control the motor. If you let go of it, it'll stop the motor. Likewise, if it's not clicked at all, it won't move. Another feature is we have a quadratic speed curve, so it's a little bit easier to control the speed at lower RPMs than higher. We also have a brake set up in the controller, so if you need to stop immediately, you can pull down on it and it'll stop, although this is a little bit risky of a feature to use. Overall, that is our electrical setup. Electrical errors that we experienced throughout this project included connectivity issues between the dongle and the remote, which we later figured out to be from the fact we were powering the Arduino from 6 AA's. After we switched to powering it through the BEC, we no longer had this issue. So we concluded this was due to the USB shield drawing too much power. Another problem we had is originally we had a 6S ESC, however due to electrical wiring issues, we shorted it out and destroyed it, but luckily we were able to find this for us that allowed us to finish this project.